Good morning, sixth graders. Today we are going to be starting the first half of our last area of probability that we're going to be studying in this unit. And we're going to be looking at independent events. And so let's start with our warm-up for today. It says, Jack and his family went to a restaurant to celebrate his birthday. He has a choice of 3 entrees, chicken, beef, and fish. He also has a choice of 2 sides, broccoli and potatoes, and 3 drinks, tea, water, and coffee. It says draw a tree diagram to show all the possible outcomes. So let's remember what a tree diagram looks like. So I'm going to use my pen. So my first choices are my entrees. So here's a choice of chicken, beef, or fish. Then he has, his next choice is the sides. So there's a choice of 2 sides, broccoli or potatoes. So do broccoli or potatoes. We have broccoli or potatoes. And last we have broccoli or potatoes. And then we have our third choice, which is drinks. So he has the choice of tea, water, or coffee. So we're going to go to our third choice. And we have 3 choices off of that. So we have tea, water, or coffee. And then we have tea, water, coffee. So we need to do that for our last items. So now we have all of our possible outcomes. So we have 6 outcomes for chicken, 6 outcomes for beef, and 6 outcomes for fish. So we have a total of 6 times 3, which is 18 outcomes. So that means he has 18 different options for dinners. Let's look at number 2. It says rolling a number cube and tossing 2 coins. It says draw a tree diagram again, but I want to do the counting principle and review that a little bit. So I want you to use the counting principle to figure out how many outcomes there would be between rolling a number cube and tossing 2 separate coins. So rolling a number cube, we have 6 options. Then tossing 1 coin would be 2 options, times tossing another coin, which is also 2 options. So we have 6 times 2, which is 12, times 2, which would equal 24. So we would have 24 outcomes. So that's a little review of our sample space. So now we are going to be looking at independent and dependent events are our last section of probability. Today we are focusing on independent events. So independent event is the occurrence of one event that has no effect on the probability of the second event. So these are the main types of probabilities that we've been working with already. So we are going to find the probability that two independent events will happen. Multiply the probability of the events together. So when we're working with independent events, we are going to be multiplying, just like we did with our counting principle. But now we're going to be working with the actual probabilities. So the probability of A and B happening is the probability of A times the probability of B. So this is a very important slide to have written down. So if you don't have this written down yet in your notes, make sure you pause the video now and get this written down. This is what you're going to want to look back at today when you are working on your assignment. So let's practice. It says find the probability of each. All items are replaced after each pick. So we have the probability of a red and a yellow. So first we need to find the probability of picking a red. So that's going to be the amount of reds over our total amount of items. So we have the probability of pulling a red is 4 over, how many items do we have? We have 4, 8, 12. So we can choose to simplify this right now, or we can choose to simplify it after we multiply. I know if I simplify it now, it'll be smaller numbers to multiply with. So I'm going to simplify. So 4/12 is equal to 1/3. So now I have my yellows. So there's 2 yellows out of 12 items. And I'm going to simplify that into 1/6. So now I need to take my two probabilities. So I take my 1/3 and my 1/6, and I'm going to multiply those two probabilities together. So I take 1/3 times 1/6, and I get 1/18. Now, let's look at our next one. What is the probability of drawing a circle and a blue? So the probability of drawing a circle, we have 1, 2, 3, 4, 5 circles out of 12 items. So 5/12 can't be simplified, so we're just going to leave that one alone. And a blue, so we have 1, 2, 3. So we have 3 out of 12. So this one can be simplified, so we have 1/4. So now we take our two probabilities. We have 5/12 and 1/4, and we're going to multiply those two together. So we take 5 over 12 times 1/4, which equals 5 times 1 is 5. 12 times 4 is 48. So our probability would be 5/48. And then our last one, what is the probability of drawing a purple and a green? So first we're going to do purple. So we only have one purple. So it would be 1 over 12 objects in all. And then we have our green, which is 1, 2 over 12 objects in all. This one can be simplified. So it equals 1/6. So we have our two probabilities. We have 1/12 and we have 1/6. So we take 1/12 times 1/6. So we get 1 over 72. So I want you to look at these three events that we found the probabilities for. Which is the least likely to occur? The least likely to occur would be pulling a green and a purple, because that is only has a 1 out of 72 chance of happening. So it's going to be our least likely event. Now I want you to practice finding these probabilities. Remember, we have to find the probability of each and then multiply each probability together. So let's look at number 1. What is the probability of tossing a head on a coin and getting a number less than 3 on a number cube? So our first probability that we need to calculate is flipping a head on a coin. So we know that the probability of getting a head on a coin is 1/2. Then our second probability that we need to calculate is a number less than 3 on a number cube. So what numbers are less than 3? We have a 1 and a 2. So we have 2 options out of 6 total outcomes. So we have 1/3. So we now take 1/2 times 1/3 to get 1/6. So our probability of getting a head and a number less than 3 is 1/6. Number 2, what is the probability of spinning a 3 and then a vowel? Looking at these spinners down here. So our first thing is the probability of spinning a 3. So the probability of spinning a 3 is 1 out of 4, or 1/4. And our next is spinning a vowel. So we only have one vowel on our spinner, which is A. So that would also be 1/4. So we're going to take 1/4 times 1/4, which equals 1/16. And number 3, what is the probability of spinning an odd number and then spinning a consonant? So the first one is spinning an odd number. So we have 2 odd numbers. So that equals 2/4, which equals 1/2. And then our next one is spinning a consonant. So that's the opposite of a vowel. So our consonants are A, B, C, and D. So we have 3 out of 4. And that one's in simplest form. So we take 1/2 times 3/4, and we get 3/8, which cannot be simplified. So our probability of getting an odd number and then a consonant is 3/8. So that is how we find the probability of an independent event. So, is the probability of 2 events greater or less than the probability of 1 event? Go back and look through your notes and think about what you know and what you can conclude about this question.